Hey there, welcome to another video in the Learn APL with Neural Networks series. In this video I will teach you how to read data from text files, and therefore if you know all about reading data from text files in APL, you can feel free to skip this video. Otherwise stay tuned as I teach you about quad NGET and quad CSV. Okay, so to start off, the easiest way to read from a file is to use the quad NGET function, system function. And in order to use it, the first thing you want is a path to the files that you want to read in. So let me go ahead and let me copy that path and let me type it in here. So the path where my files are is this one. Now, using quad NGET is really simple. You just type quad NGET and then you give it as right argument the path to the file you want. And let me go ahead and open the readme file. And that's just it. This is what we get in return. There's 3 items in here, so let me use tally to show you there's 3 things. And most of the time, the only thing you really care about is the first item in here. Now, I might be mistaken, but I think the second item tells you the encoding of the file you just read, and the third item has something to do with the line ending encodings. I don't know, it's some weird stuff that I have never gone through the trouble of really understanding. But it might happen that your numbers in here are different. So it might show just a 13 or just a 10, not entirely sure. But if you want to get technical about this, the thing you can do is you can type quad NGET and then press F1, and it should open the documentation of the function, and you can read all about everything. So you can even see here some table with some values regarding the line separators. Yeah, and so it's fairly common to see something like this. The text you want is the first item, so pick or take the first of whatever you get by calling NGET on the file path, and now we have the text here. Now what's interesting is that the path this might look like a matrix, but it's actually a vector. So the shape is just 255, so it's not a matrix. It's a vector with 255 elements in this case, and in here you have the new lines embedded, and that's why it looks like it's taking different rows in a matrix. So you could now split the text on the new lines and reshape it into a matrix or do whatever you want, or what you can actually do is ask NGET to give you the lines of the file instead of giving you a vector. And in order to do that, you pass it one extra argument on the right, which is a 1, telling you that you want the text to be an enclosed vector with the lines. And now you can do something like mix of the text, and it looks exactly the same, except if you ask for the shape, it's now a matrix with 6 rows and 96 columns over there. So this is the most basic way to read text from a file. And by the way, there's a sibling function to quad NGET, which is quad input, that you can use to write text to a file. Now, the data that we have, so let me show you, the data that we have is stored in CSV files. And sure, we could do something like we could read the whole text, so let's do text, quad NGET, and now instead of the readme, we could read, say, the MNIST, which one? The test is smaller, so let's read that one. And now we see that I have the 10,000 lines of text in here, but now I would still have to parse them. So this is what the first line looks like. It's a really long line with plenty of integers, and I would still have to parse it. And that's a little bit boring, I would say, and it's not the focus of this series. It's not parsing input. So what we can actually do is use a dedicated function, which is quad CSV, to read the CSV data. And the way it works is really simple. It's basically as simple as that. What we can do is I can take the data and say that it gets from reading from this file. So mnist test.csv. you just give it a couple of seconds, and unless I did something wrong, no, I didn't do anything wrong, and now I can ask for the shape of the data, and it says it's a matrix with 10,000 rows and 785 columns. Now let me erase the text. Now you might have noticed that it took a couple of seconds in my computer to load this, and in your computer it might be faster, it might take longer, or it might not even work. It might give a was full, so it might give an error with something like this, saying that there's not enough memory in the session, so in the dialog session, to load the whole thing. It's not saying that the computer by itself cannot handle it, it's just that APL was not configured to have that much memory available. And if that's the case, something you might do is type quad WA and take a look at how much memory you have available inside the interpreter. And this is bytes, if I'm not mistaken. So I can see that I have approximately 157 megabytes free. And it may sound like it's not much, and it's not much, but if I go to, if I go to options, configure, then I can go over there to the session. Sorry, it's not the session, it's the workspace over there, so workspace, and you can see that the maximum workspace size that I have set, so it's already an increase to the default, is 0.5 gigabyte. Yeah, and now most of this is being consumed by the data there. So if I go ahead and I type erase data, and now if I do quad WA again, you can see that now I have pretty much everything back. So it's almost completely free, my workspace. So one thing you could do if you get a workspace full error, essentially just meaning that this quad WA is returning nothing, so it's returning 0 because there's no space left. So what you can do is either increase the workspace size or don't read the whole thing at once, which is, in my opinion, the more sensible approach, not reading the whole thing. And so, in order to do that, what we will need is something called the variant operator, which is this thing over here. And now, how do you type it? I have no idea, I have to think. I just typed it by instinct. Yeah, so it's APL key, shift, bar, / I mean, assuming your keyboard is the same as mine. Again, remember that you can go to the language bar and ask for the keyboard shortcut. So it's in the third group, counting from the right. It's a quad with a colon inside. Now, you can do something like quad CSV. You know what this variant does is, it modifies the function on the left. And the way we want to modify it is by saying that the records that we want to read are at most 1,000. So what this says, this right here says that this quad CSV has now been modified so that it never reads more than 1,000 lines at a time. And you can change this value to something bigger or smaller. And now what we will do is we will read the file chunk by chunk, essentially. We are essentially reading a chunk of the file. So let me actually show it to you now. This might not work right now, so let's just see if this works. So we can give it the path to the file. Okay, it worked. So let's take a look at the data. You see that now I only read 1,000 lines. Now let's try to read the next chunk again. And now notice that I'm changing the name of the variable. So let's read the next chunk. Because if I'm going to read 10,000 lines, I need to read 10 of these chunks, right? So I read the next chunk, and we can see that it still has the same shape, so it's still 1,000 lines because there were 1,000 lines to be read. But actually, we can compare the two, and we can see that they are exactly the same. So I didn't read the next 1,000 lines. I reread the same parts of the file. So I reread the beginning of the file. And, well, why is that? It's because this in no way tells APL that I need to keep reading. So I haven't signaled in any way that I have read a part of it already and that I want to read the next part. And so the way you do that, the way you tell APL that there's a file that is opened and that is currently being read, is by giving it a tie number. And how do you do that, and what's a tie number? So the tie number is something that basically, and this is my understanding, so this is my intuitive understanding what is going on, but that's, if that doesn't suffice for you, you can always read the documentation. So my interpretation of this is you essentially open the file and you give it a unique ID so that APL and the system can refer to this open file and just work with it. And so we are going to use this quad NTIE function. And what it takes on the left is the name of the path of the file, and on the right it takes the ID that you want to assign it. And if you give it 0, I think it will look for the first available tie number, which is always a negative number. So giving it 0 is probably what you usually want to do. It assigns you a specific tie number. You don't need to worry about the actual value, you just need to have it stored somewhere. And now APL knows that this file is open. Now what we can do is we can read some data. Sorry, I'm being silly. So we do want to read some data, but instead of giving it the path, you give it the tie number. And so APL will know to look for, so it will understand that this is the tie number referring to some open file, and it will read from that open file. And now we can do the same thing. We can read some more data with the same tie number, and now we can see that these two pieces of data are no longer the same because they are different parts of the file. And now what we can do is, remember there's 10,000 lines. We have read information twice already. So let me execute this again. This makes it 3 times, 4 times, 5, 6, 7, 8, 9, 10. So let's look at the shape of the data. So it's 1,000 lines again. Let me look at the last row of the data. It starts with a 6. And I know this isn't proof, but let's just open the file. Let me show it to you, and let me go to the end. So it's a 6 there. 6 and then a bunch of zeros. And now if I read the data again, if I try to read more data, it's empty. What's the shape of the data? It's an empty matrix. Why? Because this tie number refers to a file that is open, but that we have read entirely. So we will do this. We will traverse the data and process it in chunks. Okay, and then when we are done, we can call quad and untie to say, well, to tell the system and to tell APL that we are done with the file and that they can close it. And now the file was closed and we could open it again and reread the whole thing. Okay, so this is how you read data in from a CSV file by specifying a maximum number of rows to read and using tie numbers. So play around with this a little bit and then join me again to keep going and to use our neural networks to read these data and to do something cool with it.